be discussing the perpendicular bisectors endpoints theorem. The theorem states this: if a point lies on the perpendicular drawn through the midpoint of a line segment, then the point is equidistant from the endpoints of the line segment. All it says is this: if AB is a line segment and it has a perpendicular bisector CD, then any point on this perpendicular bisector will be the same distance from A as it is to B. This applet from GeoGebra demonstrates the fact that any point on that perpendicular bisector will make this line segment be congruent to this line segment on this side. The proof of the theorem goes like this. We are given a line segment AB. It has a midpoint D, and point C lies at the perpendicular bisector CD of AB. Now we need to prove that the line segments AC and BC joining the point C with the segment AB then are of equal length. In other words, we're trying to prove that if I have a point on the perpendicular bisector, then the segment AC is congruent to the segment CB. In the triangles ADC and BDC, the sides AD and BD are congruent, because since D is a midpoint, it makes AD be congruent to DB. These two triangles also have a common side of DC. The angles then, ADC and BDC, are congruent as right angles. Since this red line is a perpendicular bisector, this angle will be 90 degrees and this angle will be 90 degrees. Hence, the triangles ADC and BDC are congruent according to the side angle side postulate. Since the common side is the same for both, this angle is 90 degrees for both, and since this line segment DA and DB are congruent, the triangles are congruent according to the side angle side postulate. Therefore, since these two triangles are congruent according to the side angle side postulate, that means that the segments AC and BC are of equal length as the corresponding sides of the congruent triangles.